Welcome to helpyourmath.com. In this video, we're going to look at 6 examples of finding intercepts of various graphs of given equations. And just to review, in two-dimensional math, there are 2 types of intercepts. We can have x-intercepts, and x-intercepts are the points on the graph that cross the x-axis. X-intercepts are always of the form a, 0. So in order to find x-intercepts, if we're given the equation, we want to plug in 0 for y, because that's what's going to be true about every single x-intercept. Every x-intercept is going to have a y value equal to 0. So we can find them by setting y equal to 0 and then solving for x. Y-intercepts, those are the points of the graph that cross the y-axis. For functions, there can be at most one y-intercept, and the y-intercept will always be of the form 0, b. And what this means, what they all have in common, every y-intercept has an x-coordinate of 0. So if we're going to find the y-intercepts, we will plug in 0 for x. Our first example, y equals 4x minus 8, this is an example of a linear equation. This is a slanted linear equation because we have a slope that's not 0 and defined. So I'm anticipating one x-intercept and one y-intercept. We'll start with the x-intercept. To find the x-intercept, we want to plug in 0 for y. So we're going to say y equals 4x minus 8. From here, we'll add 8 to both sides. Then we get 8 equals 4x. To get x by itself, we'll divide both sides by 4, giving us x equals 2. So the x-intercept is 2, 0. To find the y-intercept, I'll plug in 0 for x. We'll say x equals 0. This would be y equals 4 times 0 minus 8. 4 times 0 is 0, and 0 minus 8 is negative 8. So the y-intercept is 0, negative 8. So we do have 2 distinct intercepts, 2, 0, and 0, negative 8. Now, if you recognize that this equation is written in slope-intercept form, so you knew that this minus 8 had to be the y-intercept, you didn't need to do this necessarily, but it's good to check. They match up, so we feel pretty good about that y-intercept. This is also a linear equation. However, it's not written in slope-intercept form, so it's written in standard form. Really nice to just plug in those zeros. So we're going to say the x-intercept can be found by plugging in y equals 0. That would be 3x minus 7 times 0 equals 14. 7 times 0 is 0, and 3x minus 0 is 3x, so we have 3x equals 14. Get x by itself by dividing both sides by 3. We end up with 14 over 3, or 3 goes into 14 4 whole times with 2/3. So we can say here the x-intercept is 4 2/3, 0. To find the y-intercept, make that colon, okay. To find the y-intercept, we'll plug in 0 for x. So that would be 3 times 0 minus 7y equals 14. That would be negative 7y equals 14. To get y by itself, we'll divide both sides by negative 7. We end up with y equals negative 2. So we end up with a y-intercept of 0, negative 2. So again, this was a slanted line. We have 2 distinct intercepts. In this example, we're looking at a square root function. Square root functions can have at most one x-intercept and at most one y-intercept. We're going to do the same thing. So to find the x-intercept, what that means is we're going to plug in 0 for y. That would be 0 equals the square root of 9 minus x. What we can do is we can kind of think this through. So what number, when I take the square root of it, would equal 0? And that would be 0 itself. So what we're going to do is we're going to take the radicand, the 9 minus x, and we're going to say, okay, in order for this to work, 9 minus x must equal 0. Then we can get x by itself. I'm actually going to add x to both sides since it's negative. And then I don't have any more work to do because now we know the x-intercept is 9. And if you look back here, if you plugged in 9 up here, that would be 9 minus 9 is 0, and the square root of 0 is 0. So we're going to say the x-intercept is 9, 0. To find the y-intercept, let's plug in 0 for x. That would be y equals the square root of 9 minus 0. That's y equals the square root of 9, which is 3. So the y-intercept would be 0, 3. And we would know that there's no y-intercept, so not in this example, but let's just say we had y equals the square root of x minus 4. and then you plug in 0 for x, and we end up with the square root of -4. This is an imaginary number, which indicates that there is no y-intercept. So since it's imaginary, this means no y-intercept. So it is possible that there is not a y-intercept. It's also possible that there's not an x-intercept. So we just need to be really careful about what would cause those two things to occur. This example is also a square root, so we're going to do the same thing. The x-intercept is going to be found by plugging in 0 for y. So we get 0 equals the square root of 4 plus 2x. And again, the only number whose square root is 0 is 0. So we're going to take our radicand and say, okay, well, this thing needs to equal 0. Now let's get x by itself. We're going to subtract 4 from both sides, divide both sides by 2, and we end up with x equals -2. So our x-intercept is located at -2, 0. To find the y-intercept, this means that we're going to plug in 0 for x. So that's y equals the square root of 4 plus 2 times 0. 2 times 0 is 0, and 4 plus 0 is 4. So we end up with y equaling the square root of 4, which is 2. So we have one y-intercept at 0, 2. In our last two examples, we're looking at absolute value functions. So for this one, if you think about an absolute value function, they're v-shaped, meaning we could have two x-intercepts. So let's see if we end up with two x-intercepts here. So to find the x-intercept or intercepts, we're going to plug in 0 for y. That would be 0 equals the absolute value of 6x minus 2. No, it looks like we're going to have just one 0 here because the absolute value of 0 is 0. So what's inside the absolute value needs to be set equal to 0. And then we're going to add 2 to both sides. Then we'll divide both sides by 6. We can't divide 6 into 2, but we can simplify it to 1/3. So we end up with one single x-intercept, and that's located at 1/3, 0. To find the y-intercept, we'll plug in 0 for x. Oh boy. Okay. When I do that, I end up with 6 times 0 minus 2. 6 times 0 is 0, and 0 minus 2 is -2. So it's the absolute value of -2. The absolute value of -2 is 2. So we have a y-intercept at 0, 2. Okay, and in our final example, let's see if we have two x-intercepts this time. So to find the x-intercept or intercepts, we will plug in 0 for y. So this gives us 0 equals the absolute value of 1/2 x plus 3 minus 7. Before I decide how many solutions there will be, I need to isolate the absolute value. Right now there's a minus 7 on the same side, so I'm going to add 7 to both sides. This would give me 7 equals the absolute value of 1/2 x plus 3. Now I know the absolute value is equal to something positive, so there are two solutions, meaning we have two x-intercepts. One x-intercept is when what's inside the absolute value, that 1/2 x plus 3, is equal to 7. And we have another one when what's inside the absolute value is equal to -7. So when it's equal to 7, we're going to solve for x. We're going to take away 3 from both sides. That's going to be 1/2 times x equals 4. To get x by itself, you can either divide both sides by 1/2, which I don't recommend, or multiply by the reciprocal, which would be 2, because 2 times 1/2 equals 1, and 1 times x is x. So we're going to multiply both sides by 2. Those are going to cancel. We end up with x equals 8. So our first x-intercept, I'm going to put it down here, is located at 8, 0. Our second one, we're going to subtract 3 from both sides. We end up with 1/2 times x equals -10. And again, to undo this 1/2, we're going to multiply both sides by 2. Those will cancel, forming 1x, which is just x. -10 times 2 is -20. So our other x-intercept is located at -20, 0. To find the y-intercept, we're going to plug in 0 for x. So we end up with y equals the absolute value of 1/2 times 0 plus 3 minus 7. 1/2 times 0 is 0, and 0 plus 3 is 3, so inside the absolute value is going to be 3. The absolute value of 3 is 3, and 3 minus 7 is -4. So we end up with one y-intercept, and it's located at 0, -4. And there we have it.